Hello, guys. Morning, everyone. Let's give folks a minute. Okay. Um, let's get going. What's the latest on the design segment? Any update from your side?
Um, Actually, I was quite busy this week, so um, I couldn't move forward uh, about the.
Okay.
But yeah, we'll do from today, and
Okay.
we're partition the netlist basically, and implement the logic and memory chiplet.
Okay.
Yeah, we're bringing some designs by next week. Yeah.
Okay. Awesome. That's
Mhm.
perfect.
Mhm.
Um, Michael, have you had a chance to talk to Pratyush or Tony about this design? I don't see them here today, and they were talking about that they're gonna reach out to some professors to help us out to get started with open road on this one.
In relation to this, no, the only thing I've been talking to Patricia on was on the ADK design rules stuff, and we're trying to get some structure started off with so that we can bring the have the next meeting with the group. But as of now,
Oh,
not yet, no.
okay.
Uh,
All right. Okay. Yeah, that's fine. Um,
so
okay.
are we still on, David, for doing for this concept that we're going to create part model files for the rules, part model files for the chiplets, part model files for the assembly, and so when Sigwin creates the floor plan, we then start the process of creating the part model files for each of the pieces together.
Yeah, I think that's the overall plan.
All right.
Just we haven't gotten there yet because we are still trying to figure out what the chiplets are gonna look like. Right.
Right.
Trying to figure out what's in the guts of the chiplets. And once we have that, we'll know what the interfaces are going to look like, and then we can start creating the rest of the stuff.
All right. So I checked with JEDIC, and we have the HBM 1, 2, and 2E finished. We are going to start on the HBM3 and HBM4. The
Okay.
HBM4, the 4E, is only in the ballot process. So it's not formally released yet. But I do have access to the draft material that's in the ballot process.
Okay.
Assuming that it gets passed, is there's quite a bit of work involved in all of this, David, now. So we've got to focus on what are the pieces that you want me to create. Because it's not just when I create it now, I want to take it to the JEDIC and say, guys, validate that it's done correctly, that we didn't make mistakes in it, right?
Yeah.
When we create the part model, and then hand it over to you guys. So the more focus you can gave us the better, right?
Okay, I see. Yeah, do you speaking on the HBM4 balloting, when do you expect that to finish for the HBM4 to be published?
I didn't check, but if it's only at the committee ballot level, then it I'll let me just send Dale. The HBM4 is already published. The HBM4E is the one that's in the ballot process. So
Oh,
is HBM4 adequate for you?
Yeah, where was okay, sorry. What's the HBM4 designation?
That I don't know. I
Okay,
guess I'm going to have to look it up now. I don't know that. I just come off the phone call a few minutes ago.
is it published?
He said it was, so but I haven't seen it.
Okay, yeah, if you can
Let me I'm just checking here with the website.
yeah, I'm on the website too, trying to figure out. I do see HBM3. HBM3 is JSD 238B, March 2025. Is that oh, there's an update then.
JESD 402. I think.
Okay.
No, that's not it. That's
Okay.
I don't know. I'm going to have to get the ask Dale about it, right?
Yeah.
When I
That's
search.
Okay.
HBM3, it looks like it's JESD 238B.
Yeah. And it just got published, some update. Okay.
But if that just got published in March 25,
Yeah.
I don't see how HBM4 is getting published.
Yeah, probably would they were when you asked about HBM, that's what they were thinking. Would that be possible?
I don't know.
Okay. Yeah, that would be good to find out. Yeah, we're gonna have to fake it and make it look like for our design probably signaling.
Okay, he said Dale has responded JESD 270-4. Okay. 270-4. Okay, let me search for that. Yeah, it's not there.
Okay. I don't see it.
No, I don't see it either.
Two 270. Yeah, probably okay. 2204. It finds all other stuff, not this. Okay. All right, probably it will get released. Probably the person who has to stage the file just needs to push a button, which will happen sometime.
It doesn't go like that. It has to go to the publication group and they have to go through, make sure all the formatting is corrected and before it gets done. And
Yep.
it has to be, I don't know if it's gone to the BOD ballot. So
Oh, okay.
it might have
Yeah.
just gone through a committee ballot.
Mm. So that's kind of like OCP, right? The work stream gets done with something, and then it's a little bit of time to get everything done and check all the boxes, right? Format that. Yeah. Okay. Okay.
Yeah, but for the JEP 30, that doesn't happen the same way because that involves schema. So it's a much more streamlined process, right? Almost
Yes.
within the 1 quarter, we cover both the committee and the BOD ballot in the 1 quarter, and within typically 2 weeks after the last ballot is finished, it's published.
Yeah. Same thing with OCP, right? White paper will breeze through quickly. Then if it's a hardware specification, then it's a walking on fire exercise.
Yeah.
Yeah. Okay. All right. So for today, I guess not much of an update. Actually, we have Patricia joining us. Hi, Patricia. Welcome. I see you have found the link. This is the right link, the right time.
Yeah. Well, it was right after the meeting, and the meeting I had at this time got canceled. So I was like, yeah.
Yeah. I actually one way to let me show you something. I showed to all new folks. Give me a second to share my screen.
All right, Gail has just responded at least another month before you'll get the JESG 270 to be published.
Okay. We'll have it published just for the summer vacation to keep me occupied on my vacation.
All right. So just to be confirmed, Dave, is HBM4 the one that you need the most? Because I can start working off the pre-published documents and have the part model ready in a month's time. When it's formally released, we can just do a sanction check against it. So it's HBM4E4 the version you want?
Can I get back to you next Friday? Let me think about that a little bit.
All right, and give me a list of any other part models that you want to have, like
Okay.
any other type of interfaces. Let's get all those on the list because I'm going to be out in May timeframe, and I want to have this list be given to my team to be creative
Right.
on them.
Okay. Yeah. Let me. I'll get back to you by next Friday. I need to think a little bit in the context of this design, how we're going to do it and how we're going to fake it to look like HBM and have the interfaces and so on. Okay. Okay. So Patricia, if you go to hang on, this is not the right account. Okay. Okay. Give me a second. So we use groups IO for mailing lists and for calendar. So if you go to groups.io, there are several groups. Here's the CDX one. All right, let me post this link here. Actually, let me post the home because this is what you want. I'll post it in the chat. The Zoom. Oh, okay, here we go. Okay. So when you go to this link, you'll see how you subscribe and so on, right?
Yeah.
Subscribing will give you the basically the access to the mailing list.
Oh,
And then in here, you'll notice the calendar that we keep the calendar entries. Subscribing to calendar is actually involves 2 steps. You click on subscribe calendar and then you copy this link. And then you have to go to your specific mail client and create a new calendar that links actually. Okay, this is actually the more convoluted way. You go to your mail client and you create a external calendar and you paste this link. But I'm told that when you subscribe to this mailing list, you will also get a calendar invite that will automatically basically create that calendar entry for you.
okay.
And you can follow that. I believe so. If you go to the sorry, let me just I wanted to tell one more thing. When you go to the invite, you will see that the invite contains a couple of useful links. And there should be CDX folder. Okay, so this is the CDX folder. You go to the CDX folder, you go to demo design, and here we have some of the work that we have done so far. All right, there's a presentation about what is included in the design, what the current kind of this is previous version. We're going to change that. We're in the process of changing that. Things like that are here. Okay.
All right. So I guess you guys are going to do like so you guys want to have RTL for all of these chiplets and get it through PNR?
Okay, so let me tell you then where we are. Actually, Singmin, you shared the slides last time.
Yeah.
Let me see if I can find them, if I can find the link which you shared.
Yeah.
Okay, so Sigmund has been doing all the hard work. Basically, what we are looking for is kind of a chiplets with die-to-die interfaces and memory chiplet with another die-to-die interface, right? In a perfect world, we'll have real UCAE and real HBM interfaces. But since we are working kind of in the open with and trying to keep the design open, there are no open source models for any of those, so we're kind of faking those. We're calling it UCAE, but underneath is going to be just a simple IO buffer, right? It's going to have the UCA bump map, but it's going to have simple IO buffer and it's going to have AIB bus running on top of it. Probably same thing for the memory side of things. We'll either do it UCAE bump map and call it a memory chiplet, or next step would be if we can fake it to look like HBM interface, although it's simple buffers, right? Just make it physically look like HBM, but logically it's going to be just simple buffers going across. This is tiled RISC-V Ariane cores. Singmin has created the RTL and the AAB bus wrappers to talk to the outside world.
Yep.
So any other RTL that so when you ask about RTL, what did you have in mind?
Well, and the reason why I wanted to join your meeting is because you mentioned that, but basically, so I'm trying to do something similar for the HPC AI modularity work stream. I don't want to go all the way to the PNR, but I want some real numbers. So basically, what we have is that we have different AI algorithms that we have already profiled. So we know we know how much performance do we need out of the D2D interface. We know how much performance do we need out of the HBM interface, out of the for example, some applications don't necessarily need HBM. They could go with a DRAM, and then others can go just without DRAM because we can fit everything on chip. So basically, so we know what we want to put there. And what I was hoping to is to get to a point where we can evaluate this. And that was kind of the RTL that I was thinking about, like the one that you put inside each tile.
Okay.
And basically information about the tile to die to die interface. I think it's something similar to what you guys have here. That's what I was hoping to get soon as part of the work.
Yeah.
Basically, so we basically need like 4 different chiplets to build. So, this is modularity. So we care about
Yes.
modularity. So basically we wanted to have like all the possible characteristics that we can get out of these 4 different chiplets that we have identified, and then try to build all these systems. I feel in a very similar way that you guys are doing here.
Yeah.
So
One of the things so the difficulty we have is because we're doing this in the open, we work with open source libraries,
yeah,
which are not necessarily meant to demonstrate, right? If you're looking for performance, you will probably have to hand wave some of the things, right? Meaning these libraries or whatever they are, they're probably all technology node and something like that, right? So if you want to compare to a very advanced technology node, probably have to do some extrapolation and predict where it's going to be, right?
yeah, I agree with that.
Right.
Mm.
Okay, so when you talk about die-to-die interface, do you have the die-to-die interface, or you don't have that, and you would be okay to have a fake die-to-die? Let me put it that.
Yeah, so like we've gone through many iterations of this idea. So I mean we're not I think that you guys are closer to get something like more like a demo, real demo. Like in this case, everything that we have, like what I was hoping to get is to a conceptualization. So yeah, so we don't have like a real UCI interface. My initial idea was, I have something like I have you guys maybe have heard about Mosaic, which is an FPGA based tiled system. So what I was hoping was to modify my interface tile to tile so I can, the same thing that you guys are doing, mimic the delay for UCI.
Yeah.
That was the first
So
thing I was hoping to do, but then like I won't be able to actually model AI things in an FPGA, so I have to put it up a level and say, okay, just conceptual.
yeah. So is your RTL proprietary, or it's open, or it's kind of somewhere in the middle?
Actually, that's something that I haven't I mean, we need to work with open source. So, and there are plenty, there are, I think, 2 or 3 AI generators. Sorry, it's yeah, like GEM, basically general matrix multiplication generators that we could use that are open source.
Okay.
That will give us the RTL for that part. And then for the memory, we can, that's difficult because I know there is an open source generator for that. But that won't give us like a large memory. I think it kind of fails up to 2 kilobytes.
Which open source
I think
memory?
it's part of the one that you mentioned at the beginning, road lane, I think, or the
Open road?
open road, yeah, that one.
Okay, so as far as memories,
Sorry, and I'm
so
talking about crash pads, not DRAM.
um, open road is meant to be more closer to real silicon. What I mean by that is the memories which are generated for open road typically will have physical views, right? We'll need to have physical views.
No,
And that kind of will limit you to how big of a memory you can create. However, the OpenRAM compiler that I kind of is used around the open source industry. So I have used that. It doesn't have, it can generate logical views for any size of memory,
well,
right?
that's good to hear because I don't remember the name of the tool exactly,
Yeah.
but right here, and we couldn't go beyond 2 kilobytes at that
Oh, no,
moment.
no. Okay, yeah. No, okay. So take a look at OpenRAM.
Mhm.
It can generate logical views for any size of memory. And I think we generated once before for 32 megabyte memory, external memory for level 3 cache.
Oh, really?
Yeah, it just generates a logical view, which is basically it gives you this ginormous bus and it gives you Liberty file.
Mhm.
And that's it, right? If you're trying to run it will give you the behavior model for that. Now, timing is obviously going to be wrong, right? But if you want to fiddle with the numbers, you can definitely do that. But it will give you the behavioral model, and it will give you Liberty file, things like that, right? As long as you don't want to go into physical representation of that, you're good to go.
Yeah. Well,
Right.
that
And you can always fake that into a chiplet, you call it a black box and you give it the Liberty file and the behavioral model and it's done. That's kind of what we're thinking around this particular design too, right? If we need to get to very large external memory, we'll just create a logical view, put it in a chiplet and call it a big memory,
yeah, a memory chiplet. Yeah, exactly.
right?
Yeah.
Yeah.
Mm.
I think it's going to be very interesting if we can add some AI chiplets to this to this design. Uh,
Mm.
the way Sigmund has set this up is CPU cores. Actually, they have a NOC piece, but at least on the external interface, it's a simple AIB like thing, meaning it has the control pins for AAB, but these just get mapped internally to something else, right? And it's pretty much wire mapping. But
Yeah.
you can call it AAB, but it won't have all the bells and whistles of AAB, right? If you want to program any registers, things like that, right? It just looks like AAB bus.
And
I-
and for
If we-
that you're
if
gonna mimic, I mean, okay, go ahead, sorry.
yeah, so if um your chiplet can have AAB bus on its interface, then we can connect it to our CPU chiplet. It's a RISC-V open source, so if you want, you can actually write the code. for the CPU and talk to the AI engine and do fun stuff with that.
Which kind of RISC-V are you guys using?
Again,
Ariane, okay. Mhm. So you're assuming that you're gonna put one Ariane here in tile one, and then in one of the tiles, it doesn't matter, and then other things in the other tiles. Is that right?
so not entirely. Yes, yes and no. It's a little bit more flavored than that. So what we want to do is show a little bit of kind of chiplets with different technologies and possibly different performances.
Mhm.
So one of the thoughts was we can create the tile in two different technologies. And because of the density, we are actually going to get a different number of actual cores inside each tile. Right. In one case, we may get 4. In the other technology, we may get 8. And then say, see, we can gain this how we our again, all this exercise is exactly on the early planning of chiplets, right? How you put the interfaces, what you can fit, how you route them on the package, how you connect them, right, to give you that early exploration, right? Because once you get into layout, I mean, final sign off and things like that, that's not very interesting, right? It's already decided what goes on the chiplets.
Yeah. Okay. Yeah, no, I think we're trying to do something similar. I don't think we have the resources to get it to the level, to the physical level that you guys are getting it, are taking it.
Yeah.
And we want to do to prove modularity, and then we want to
Yes.
prove for artificial intelligence.
Yeah.
So
So yeah, so when you talked about the resources, sorry, I missed that. You said you don't have or you do have?
oh, we don't. I mean, we don't. We're
Yeah.
just trying to get organized around that.
Yeah, we also don't have we are also resource constrained. We've technically been dragging this for a very long time now. I would say, what is it, couple of years? Definitely more than 1 year and a half, so something like that. So maybe we should talk and see how do we help each other, right? If we are all resource constrained, maybe instead of everybody repeating other people's work, right, it would be more efficient if everyone does a little piece, and then we can get to the target a little bit faster.
I agree. I got very excited when you mentioned that during the meeting, because I mean, I like that there are other people thinking
Yeah.
the same things, and then maybe, so I would love to join a little bit of efforts and try to. So basically, our target is a white paper out of the exercise. I think, I mean, your target is a demo, so I think you guys are gonna,
Yeah.
which is quite interesting. But
Yeah.
I guess we can get that on the way, and
Yeah.
help each other. I agree.
When is the modularity meeting happening? Is it on the OCP calendar? How do you?
It is on Tuesdays. It is bi-weekly. It is I'm gonna say Tuesday, 9 a.m. Pacific time. I think we have a meeting this coming.
Is it on the this is the calendar that
Tuesday.
Tuesday.
Okay, let me check. Wiki.
This is security, advanced coding facility.
It is by,
Maybe
so it might not be that day.
maybe this Tuesday.
This Tuesday there is one coming. I'm
There's
surprised.
a digital twin workstream. Is that it? Is that it?
No, it is called HPC and AI modularity. We have one coming, so and this is going to be on. So
Okay, can you forward me that invite? I think I would be interested to join and hear what you guys are talking about.
yes, I'll do that. So oh wait, sorry, I'm a little bit next week. Yeah, so we do have one next week on April 1.
April 1st. Okay, let's see.
And then
There's
actually there in the link, it is in the wiki. We have the information on the wiki.
okay.
And
Why don't you post the link to the wiki here?
what do you mean in this
Post the link to the wiki in the chat for the.
Oh yeah, I put it. It is in the chat. I put it here in the
Oh,
meeting.
you already put it? Okay. Oh yeah. Sorry, I didn't see it.
No. If you go down, there is the HPC and AI modularity.
Oh, okay.
And I have to be more. I have like I haven't used these groups IO much, but
Okay.
I have to double
Okay.
check.
Yeah.
So,
Let me. Okay. Now that I know where to find it, how to find it, let me post it here. Let me add a bookmark to this. Oh, I actually already had a bookmark. That's okay. So the HPC modularity. Okay. I will. No, 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 no.
Here's the subscribe to the group, and there is the call link there.
Subscribe to mailing list.
Mhm.
And this, yeah, this group say, okay. Plus subscribe, okay. Okay, and I will, okay, I'll get the, so, okay, I got it. All right. I'll join you next April 1st. Hear what jokes you guys, how good are you guys at telling jokes, and yeah, and see what we can do. Yeah, I think that's a good idea. I think there's even Jawad was he was talking about everybody's looking at the same problem, right?
From perspectives.
So we have to put a stick in the ground somewhere and okay.
I would say I don't know if we're gonna talk about this coming weekend because I think I'm not sure. I think Alan is gonna talk about something.
Okay.
Yeah, but I'll yeah, that would be great if you can join and we can talk a little bit more about this.
Okay. Yeah, that's fine. Well, I think I'll start joining you guys. I've heard about the Workstream, but I wasn't sure how to find the meet the calendar entry for that. Because because it's not in the main calendar. So I'm glad we talked. So I will swing by on Tuesdays and try to keep up with what you guys are doing.
It's awesome.
Okay, so I think I don't have anything else for today then. Any thoughts from anybody, Vikas? Any thoughts from you? Boom. Okay. Sigmund, Michael.
No, nothing else. My side.
Yeah, nothing on my side as well. Yep.
Okay. All right. Awesome. We'll meet next Friday then.
Yep. Happy
All right.
Friday. Yep.
Yep. Happy
Bye.
Friday, everyone.
Thank you.
Bye.